Hello and welcome to today's event to support our electrical power systems engineering course, and this is for the online and part-time programme. So thank you to everybody who has joined us today, but if you are watching back again, thank you for taking the time to watch the online event back. So just to give you an idea of what we're going to be looking at today, and what we'll cover in the event. So we'll be looking at the University of Manchester, and we'll also look a little bit at online and blended learning. We'll go on to why study electrical power systems engineering. And then we'll also go into a bit more detail regarding the course structure and the dissertation. And then we're delighted to be joined by one of our recent graduates, David Bain, and David's going to talk through his dissertation project. So it's a bit of an insight session to just provide you with an overview of the course and what you can expect if you are to join us as a student. We're also going to host a Q&A session as well at the end of the event. So if you've got any questions at all that you'd like to ask either James or David, just pop them in the chat function and we can go through those. If you are watching this event back, again, please do still email your questions over, and you can send those through to studyonline@manchester.ac.uk. Okay, so firstly, why the University of Manchester? So we're a globally established and recognised institution, and we have a history which can be traced back to 1824. We have over 40,000 students. That's actually one of the largest student communities in the UK. And of the 40,000 students that we have, 8,500 are postgrad taught. And we also have over 11,000 students, international students as well. And again, this is actually one of the highest international intakes of any UK university. Due to our pioneering research and renowned reputation, the University of Manchester is placed high in both the UK and international rankings. So as of 2021, the academic ranking of world universities has Manchester placed 5th in the UK, 9th in Europe and 35th in the world. So as I said, you know, a lot of you will recognise the university and brand, and as I said, that's because we really do have that international presence as well as achieving high within the UK on the rankings. Another fantastic recent achievement by the University of Manchester is that we've been named the world's #1 university for action on sustainable development in line with the UK's Sustainable Development Goals. And you can find further details on the University of Manchester, our achievements, all the research projects, and also exciting future plans, and you can find all of that on manchester.ac.uk, and that's the university website. In terms of looking a little bit at online and blended learning, I just really wanted to briefly touch on this because I think it's quite important to point out that as an online learner at the University of Manchester, you have access to the same resource and support as those students studying on campus. So you'll enjoy the same level of teaching, and you'll have access to our libraries, our networking groups, our wellbeing services, and you can even request a student card as well, which I know sounds a bit odd considering, you know, it's online learning, but it is something that's equally important to a lot of our students. It's something we're asked. So again, even as an online student, you would have access to a university student card. And again, so why study an online and blended course? Well, it's flexible study, so you can work where and when suits you. You can develop your career without taking a career break, and it's convenient learning which fits around your lifestyle and commitments. And as such, you'll have access to a global network, allowing you to join a worldwide community of learners. And again, you can find further details regarding online and blended learning on the university website. Alternatively, if you do have any questions at all, just email me, and I'm on studyonline@manchester.ac.uk. Okay, so now to tell a little bit more about our online part-time electrical power systems engineering course, I'd like to hand over to our course director, James Brooks.
Hello, and thank you everyone, and thank you Lisa for the introduction. So a little bit of background to myself. I'm the academic course director, so I have an overall responsibility for the programme and spend a lot of time thinking about what the right mix of things is to go into it, making decisions about how various things should be structured within the course. And I'm there to, I guess, help out and guide you on through your journey on this course. My background, so back when I did my PhD, I was looking at risks across a power system where there is a lot of wind power. So it was a sort of computer modeling and statistics and kind of based analysis of high penetrations of renewable power. But now I focus much more on education quality within engineering, and actually I spend a day a week, or now 2 days a week, working with other program directors, working across science and engineering, trying to improve the quality of teaching, and hopefully that's reflected in what you see in this course. I'm also a senior lecturer in electrical engineering, and I teach on a number of the units that I'll talk about later.
Hi everyone, my name is David Bain. I am a senior engineer within Ofgem at the moment, so a little bit of background on me. I joined SSE about a decade ago, and I went through their technical staff trainee programme, which allowed me to get a foundation degree from Aston University. I did various roles within SSE, mostly surrounding protection and control systems, so I did a lot of work in that field. In 2017, I joined the EPSE Masters Distance Learning course at Manchester, and I graduated in late 2020. And yeah, as I said, I've recently joined Ofgem as a senior engineer. Thank you.
Right, and then I think it's back to me for why study this specific course at this specific university. So I think Lisa's already kind of given the overview of the university, but if we think about just this discipline, the electrical and electronic engineering, we're one of the top institutions, one of the top 3 for this subject. A very high percentage of our research is world leading or internationally excellent. And so our current work is very well renowned in the research field. We're doing a lot of industry collaborations and projects and research projects around the world, but we've also been doing this a very long time. I think we were one of the first power systems master's courses anywhere, and that is been in continuous kind of operation, has been running for that long. And we're also quite a large department. We've got people who specialize in so many different areas that, their background actually comes from chemistry, looking at transformer oils. It comes from the physics of breakdown in conductors and insulators, people looking at sort of mathematical modeling and simulation and testing, people looking at salt fog chambers, battery storage, protection. So it's nice to have that breadth of skills in the academics that can feed in, and particularly feed in when we're talking about dissertation supervision. Onto the course itself, we've designed this course around study so that there is more flexibility. As you say, it is part-time, but there's also the ability for people to say, well, look, I know there's a big work deadline coming up, or I know I've got I'm taking a long holiday, then I'll just take a break of study for the next, I won't study this unit. So it does allow some flexibility there in how you study. And the sort of the capstone, the final third of the master's, is on this dissertation that doesn't have to be, but tends to be focused on a work-based problem. The other kind of major point about this is it's IET accredited for further learning, which means this is the sort of the stamp of approval from the Engineering Council and the Institute of Engineering Technology, that it is part of the foundation for reaching this professional registration for something like a chartered engineer. And a number of people, actually including David, have either got their chartership and use this as part of their application, or are going through it now and in the process of sort of putting it together. And we've actually been working with the IET to try and support people through that process. The other thing that I think is a major selling point of this course is that there are people, is sort of the cohort that you will meet and you will work with and get to know. So we have people who work in sort of the big engineering consultancies and manufacturing firms, with people working in the various sort of asset owning companies, so the transmission and distribution systems. We have people who work for system operators, people who work for, what else have we got? We've got people who are sort of the high voltage specialists in particular industries, so high voltage specialists in oil and gas or in data centers or things like that. So it's nice to be able to have these conversations between, let's say, someone who's doing the same job as you in a different country, or someone who is using the same piece of kit as you, but maybe they're on the design team and you're on an implementation side in a different company. In terms of what the course actually looks like, there are sort of 3 points at which you can get a certificate. So if you just do the first third, that's the first 4 taught units, that will take 12 months part-time, and that's the PG certificate. If you go on from that to do all of the taught units, so the first 2 years, that would be the postgraduate diploma. And then if you do the final piece, that capstone project, that gives you the MSc. That would be a minimum of 2.5 years, although normally people like to take a full year for the dissertation, which is the full length of it. So depending on the commitment that you want to put into this or the time you've got, you can choose. And also you can jump between these fairly easily. The entrance requirements are the same for the 3. So once you come in, you can have a discussion with us about what you want. In terms of the material we actually teach, we've got a whole lot more information of kind of what's in each of these on the web. But we start off with making sure everyone's up to speed with how to study at master's level, doing independent research and reading published research papers, basics around 2-bus power flow modeling, power flow and faults more generally. Then we go on to physical assets. We have some fantastic people who worked in R&D in industry and are now coming in back into academia to teach those and have some great conversations about, you know, what's in a substation, what are the design decisions, what's the ongoing maintenance and monitoring for that. We then jump to a more mathematical theoretical unit on mathematical optimization, economics and operation. Then on to the future of power systems and what they could look like, getting people to do literature reviews on a particular kind of new topic in sustainability and smart grids, and work with a number of pieces of industry software for modeling and simulation. Then looking again a sort of similar thing on the dynamics and quality of supply side, and then protection, again using a mix of examinations and software. And then finally a unit that sort of pulls this together, where you will produce a plan for an innovation, working in teams within there. So it's building these research skills, building some of the sort of the business skills that then will help you when you go into the dissertation. And if we move on, I think that's the next piece. So the dissertation is designed, or the deadline is 1 year. You'll be assigned an academic who's happy to supervise a project in that area. Maybe they've already got a research grant. So one of these, I think it was actually the blockchain for substation communications. The academic that was assigned to that student was had a big industry funded research grant in this area, and the student was working in a related area. So it really nicely sort of paired together research, the academic and the student kind of contributing their own skills from, you know, they had quite a knowledge of the blockchain side, and the professor had a knowledge of the substation, the digital substation side, and kind of goose protocols and security, information security. But it might be an academic that works on a number of different areas, and is sort of happy to supervise and support you with what you need. You choose the topic, so you will come up with a proposal saying, I want to work on low inertia systems. We'll sort of flesh that out a bit with me, and then I will assign an academic to you, and you work then with the academic to decide or to agree upon what your project will actually look like. And that counts as a third of the MSc mark. And just to give you an idea of some of the areas people have chosen. So a substation engineer knew that the area, the sort of facility they worked in was looking at transitioning to be a digital substation. And so that was their MSc topic. They were looking at what options are available, what sort of technical solutions would be right, what's the sort of coming trends, what are people doing in different countries and different areas, and that sort of formed the basis of their research. There was a few where there have been people working in a transmission or distribution system that have got models of their system where maybe they'd done a static analysis, or maybe there'd been an analysis that was good enough for a project, but they wanted to dig in deeper. Maybe there was something interesting going on, and we can kind of work with you with the data you've already got around that. There was other ones on quality of supply, again in a particular site. Some of them have been more abstract, so we can provide data either from projects we've run in the past or sort of standardized ones. So there are standard test systems that we can provide if your company's not able to share that data. Although we have worked to produce non-disclosure agreements if that's a requirement for it as well. I'm happy to answer a lot more questions about this if people have kind of particular things they want to know. But I think it might make sense to talk to David, who did a dissertation and did very well, and he can tell you about what that was like and what he did it on, I guess.
Wonderful, thank you, James. So yes, we'd like to focus now on the actual work-based dissertation project, and as we're delighted today to be joined by David Bain, and David is one of our recent graduates. So David, I know you obviously provided us with a little bit of an introduction earlier, but could you just maybe tell us a little bit more about your place of work, and obviously maybe where you're based, some of the projects that you're involved with?
Yeah, sure. As I said, I work with Ofgem now, so I'm a senior engineer within their engineering team. So I'm based in Aberdeen, but the Ofgem office I tend to work from is in Glasgow, so I go there on occasion. And at the moment, big area of work for me and pretty much everyone else in Ofgem is the Rio ED2 price submission. So yeah, that's the main sort of focus of my work at the moment, Lisa.
That's it in a nutshell, in a very short couple of minutes. And David, what were your reasons for studying the course with us? What made you sort of decide to undertake? Because I know it's a big decision, obviously, with you working full time as well.
Yeah, I was interested in professional registration. So I had my foundation degree, and chartership's a lot easier with an accredited master's to your name, so that fed into my decision. I was also sort of going through a period of sort of like I was just touching 30, so I was a bit reflecting on my career today and where I wanted to go. And I had a realization that I worked at that time as a protection engineer, which is very interesting, quite technical, but it's very specialized. I would say it's quite a microcosm of the industry. and I maybe felt that I wanted to have a bit more of a macro view. So I identified that maybe I needed to do a bit of upskilling and learn a bit more about other areas. And also, I kind of there's major work happening in the industry at the moment, you know, decarbonisation, etc. So I think there will be opportunities for engineers who wish to upskill and then perhaps go and work in, you know, different part of the country, a different part of the world. You know, I think there's it's a time of real opportunity within our industry at the moment. So all those sort of fed into my decision.
Fantastic. Yeah, like you said, there's absolutely loads of opportunity. It's definitely at the forefront at the moment, isn't it, to the industry?
Yeah.
And just looking a little bit more then at the dissertation project, because as I said to you before, you know, we're asked by a lot of prospective students, you know, what can I expect? How do I pick the topic? Do you pick that for me? So could you just tell us a little bit more about that? So maybe the title of your dissertation, what the focus of it was, and obviously how did you, I suppose, fit that into your work, and were they supportive of you as well? Because obviously it's a big commitment.
Yeah, so the company I worked for was basically footing the bill for my master's, so I felt a sort of need to do something that was relevant to my area. And you could argue there's a bit of strategy and a bit of pragmatism in that as well. You know, if you're not starting from not knowing nothing about a particular topic, so there is that too as well. So yeah, they were very supportive of my dissertation. Initially I cast quite a wide net, and Dr. Brooks and my supervisor did have to rein me in a little bit. So I'd originally I knew I wanted to do something with protection, and one of the big areas of interest for me was the huge increase that we're seeing and is expected to continue and will continue, I think, of distributed generation and what impact that has on traditional protections. So I did a lot of reading around of the academic literature and got a feel for the sort of state of the art. And I sort of asked myself, what do I want to achieve with my dissertation? You know, I can't really compete with some of these really interesting papers because they've been using our TDS simulators and doing all sorts of complicated things. But I did identify that not much work had been done on a specific type of protection called distance protection. So I sort of iterated my project focus down into the catchy title of Distance Protection of UK 11 kV networks with distributed generation. And I'd sort of identified in the literature that yes, there are issues with using distance protection alongside distributed generation. Essentially, distributed generation inserts more sources of fault current into a network, and so distance protection will underreach, it won't operate particularly well, essentially. And the literature also pointed to the fact that there was a lot of issues around distance protection in multiple earth networks with lots of distributed generation. So that's not the case in the UK. We actually use a single point earth, and so I sort of quite quickly zeroed in on this idea that maybe there's something in this. So yeah, I sort of narrowed myself down onto that. I did some sort of just paper modeling, just quick maths, basically. And I sort of thought, well, it maybe kind of works. So my idea was broadly that I could build a network, an 11 kV network in a modeling software, which actually my company sort of let me use. I could model the protection relays. The software was able to do that. And I could put various types of technology and various capacities of distributed generation on there. And I could use various network topologies and ascertain how distance protection would actually perform in that scenario. And my idea was broadly that, yes, distance protection will underreach, but is it a problem if you have distance protection everywhere and then very quickly you get rid of these additional sources of fault current and the distance protection underreaching will begin to reduce? So it was really interesting. It was very applicable to the job I was doing. I didn't conclude that we should use distance protection everywhere and that I'd solve the problem, but I think maybe one aspect of the dissertation, you can actually say, well, I've looked into this in great detail. It does kind of work, but not brilliantly enough for it to instantly be a solution. So here's future work that I could do if I wanted to go on and do that. So yeah, it was really interesting. It ended up being, and I didn't expect this at the start of my journey on the master's course, it ended up being my favourite part of the course. That's the bit I enjoyed most. And if I was to sort of encapsulate the sort of main benefit to me as an engineer, and this is definitely the dissertation, but broadly the units as well, I think my research skills improved enormously over the course of the program, but in particular during the dissertation, because I did a lot of research and I got very used to doing literature reviews, and I do that. That's quite a big part of my job, is actually being able to quickly identify relevant sources to basically educate me on various different aspects of engineering. You know, engineers aren't paid to know it all, but they are paid to sort of be able to go and find out things. So that's how I see it.
And I believe James David did exceptionally well with his dissertation, didn't he?
Yes, you were one of the highest marks I've seen. I was really impressed with what I saw in it, and you're not going to solve everything in any area. In fact, it's always, we say research is fractal. The more you look into an area, you clarify some things, but you realize actually there's more to it, and there's always more to it as you go down. And you know, people see the same when they do a PhD, and they do the same when they do research. But really clarifying what the area is, what's known and what's not known, is a really useful contribution. And it's great that your work was both interesting from an academic side, but also from a practical side. And I believe you also were writing it up for a not publication, but a conference, weren't you?
My academic supervisor and I, Professor Crossley, who actually, just as an aside, one of the other key benefits of doing a dissertation is access to academics in maybe a less formal setting. I really did get a lot out of the sort of peer-to-peer learning. I spent a lot of time having chats with Professor Cross that lasted hours as opposed to the half hour that we'd scheduled. But yeah, we did discuss writing up for a conference paper, but I think Professor Cross retired actually, so we decided, luckily, we decided against taking it any further.
I was quite keen that you would, because I knew it was worthy of that quality. But yeah, it is a great benefit to have that time to chat and to get kind of open feedback and discussion with someone who's a researcher in that area, who can not only guide you but provide you kind of their background and their insight. But yeah, great to hear that process went well for you.
And David, do you have any advice at all for, as I said, we're joined today by many prospective students considering joining us and studying the course. Do you have any advice at all for students in terms of how you did juggle that workload, studying, getting through your dissertation?
Just a bit of background on a personal level. When I started the course, my wife and I had, I'm not sure how old she was actually, but a months old baby. She wasn't old, less than a year. And so, yeah, I had a busy home life with that, obviously busy professional life like everyone else. It is a bit boring, and I know people will be frustrated when I say this, but really discipline and organization is the key to this. I wouldn't underestimate the undertaking, but it is possible, definitely. And I know that for those that have been out of education maybe for a little while, this course maybe appeals to people that are, well, it does appeal to people that are employed and maybe been out of formal education for a little while. There is that daunting aspect, maybe returning to study. What I would say about that is that my experience at the University of Manchester, I was afforded all the sort of tools and the support and ultimately the opportunity to succeed in my studies. And yeah, just touching on the dissertation, because I know there is, we spoke, Lisa, that people ask an awful lot about the dissertation. And I remember when I was thinking of joining the course, the dissertation anxiety was real for me, because I was thinking, oh, there's no way I can do that. That just seems too much. What I would say is that you know, I wouldn't belittle anyone's anxiety around that, but you have 2 years of preparation. I think Dr. Brooks touched on it earlier, where I wouldn't say everything's geared towards doing your dissertation, not at all actually, but you learn the skills required to do your dissertation. So I mentioned literature reviews. You will become very adept at researching suitable literature. You'll become very good at reviewing that literature. And yeah, you, as I said, I didn't expect it to be, because I had all this anxiety around it. But the dissertation ended up being the most enjoyable aspect for me. And probably the key aspect of the dissertation, I would say, is to kind of choose something you're interested in. Obviously, you don't want to spend maybe a year of your life doing something that you don't want to do. As Dr. Brooks mentioned, it's ideal if it can have an input to your work, to your working day. There's also a bit of strategy and pragmatism there, because, as I say, you don't start from scratch. You have a fair, I mean, I was a protection engineer, so I had a fair idea about distance protection. So yeah, there's that part of strategy towards it. And then just making a start. Once you make a plan and you agree on a topic, just make a start. And once you start reviewing it, it genuinely isn't as bad as you build it up in your mind to be, would be my thing there.
Very reassuring words indeed, David. Just take that. No, that's brilliant. Thank you so much for, as I said, for just, you know, being so honest and obviously saying how you found the dissertation, because as I said, it's huge, isn't it? To undertake the course, you know, just to do a PG dip in is massive anyway, dedicating the time to your studies, and then to add the dissertation on the end. I said that dissertation anxiety, I'm sure, must be prevalent for a lot of prospective students. And what about now that you've graduated? What sort of future plans do you have? Now you've got some free time, dare I say, even though I know you've got another little child.
Yeah, I think it's just off camera, but I took up the guitar. It's amazing how much free time you get just as soon as your master's ends, because you're used to doing 2 to 3 hours studying a night, and then so all of a sudden it's like, oh my, what did I do with my time? So I did that. I recently had a sort of slight change in career, so I moved to, as I said, to work with Ofgem. So yeah, I'm ongoing with my professional registration as a chartered engineer, so I aim to get that submitted this year, and hopefully in the new year get it. And also, you can maybe call me a glutton for punishment, but I have actually been starting to think about potential MBAs. So I'm actually, I enjoyed the distance learning aspect. I think it suited my learning style so much that I'm looking for sort of a similar delivery method in an MBA. So yeah.
Fantastic, exciting times then.
Yeah,
learning.
I'm sure my wife agrees.
That is wonderful. Thank you so much, David. And that goes on quite nicely to our next sort of area to look at with regards to the course. And that's just, again, James, I'm just going to hand back to yourself, if that's okay, just go through a little bit of the course delivery and what our students can expect.
Yeah, happy to talk about sort of the way it was designed and what to expect from it. So the course was, actually maybe David can come in on this one as well. The course was designed to be 15 hours a week during each of the sort of 4 10-week teaching periods. So there's 4 blocks of 10 weeks, and in that a year, and in that time there's 15 hours a week of study. But David, I don't know what your sort of experience of that was.
I would broadly agree with that. You do have perhaps weeks where you're not quite fully 15 hours, and then there's other weeks where you're a bit more. So yeah, on average 15 hours.
Okay, yeah. And then for each of the technical units, so those 8 taught units, you'll get an academic tutor. So I tutor the first and end ones. I sort of cap the dissertation, who will have expertise in that particular subject. So as I say, we have people who've worked as academics or in R&D, so in protection and in plant. We've had people who work in industry for decades and now have come into academia, or they're professors and lecturers in the area. There'll then be one or more pieces of coursework and a final assessment. So often the coursework is software based. So it might be using PSCAD or PowerWorld or IPSA or something like that to run a simulation. And then you write up a report and analysis as a piece of coursework. 4 of the assessments have exams of a sort of more traditional format where you'll get given an exam paper. At the moment, they're run online due to the pandemic. Prior to that, they were physically in normally the local British council to whichever country you're in, and we have a few places in the UK as well. And you do an exam for those. And as I say, we kind of give you access to the software that will allow you to do the analysis relevant to that unit. In terms of what we require from you to come onto the course, the standard requirement is a 2-1 honours degree in something relevant. So when I do my part of the application process, I'll be looking particularly for maths, because there are quite a few maths heavy units. There is quite a lot of mathematical analysis in this degree. And there's also, the basics around power systems, circuit analysis, that I'll be looking for as part of your degree. So normally it would be an electrical engineering or similar degree that you've got at that level. Now, if you don't quite meet those requirements, if you're sort of narrowly off in an aspect, there is an alternative entry route where you'll take the first 2 units, and then at the exam board, we'll reassess you and move you on to the rest of the program. And I believe, David, actually, you came through that route. I'm trying to remember because it was a few years ago. Oh, you did? Okay, yeah. So if you're narrowly off the 2-1 in honours degree in something relevant, or whatever your international equivalent is, then what I'd recommend you do is get in touch with Lisa or one of the other people who works under the email Study Online at Manchester, and they'll be able to give you some more advice. We also have 2 intakes a year. So there's one coming up in February, towards the end of February, and one in September. But you will need to have your applications in, and you can apply now, and you can ask some questions and get sort of detailed feedback through that.
Wonderful, thank you very much. I just want to move on. I've had a couple of questions come through. I know someone's again just asked, David, I think you've already addressed this, but roughly how many hours a week did you spend on the course? Which I think we said 15, would you say would be about correct, what we'd put down?
Yeah, I mean, I could expand on that a little if you like. I could talk about my schedule and sort of what I tended to do.
Yeah, that would be great. That would be brilliant, actually, because a lot of people, when you do say, well, it's 15 hours a week, you think, well, how do you fit that into your day? So if you've got any sort of tips for students, that'd be wonderful.
Yeah, I mean, I preface it saying it sounds worse than it actually was, so don't let this put you off. But I used to, after I put my daughter to bed, so around about 7, half 7, I would sit down and do a couple of hours Monday to Friday, maybe 2.5 hours. And it's important to take regular breaks and stuff, but 2 to 2.5 hours. And then anything additional I needed to do, I would sort of mop up on a Sunday afternoon. And as I said, yeah, broadly, about 15 hours on average is a good yardstick. There'll be times where you don't have to do that, and then there'll be times where you're doing a bit more. So yeah, around about 15 hours isn't bad.
Thank you. I know we've had a few questions come through just in regards to eligibility for the course. As we sort of touched on already, we do really need to see more information so that we can really assess your application. So if you have got a question in regards to eligibility, if you can please email me at studyonline@manchester.ac.uk, and then we can pick the conversation up there, because I would like to see your degrees transcripts and also a little bit more information in regards to your professional background. So as I said, I know we've had a couple of questions come through regarding that, but if you could please just email studyonline@manchester.ac.uk, and I can then pick those up directly with you, because I said there's quite a lot that we look at with regards to applications for the course.
Can I just kind of come in on that as well, Lisa? So if your degree isn't in, let's say, electrical engineering, The things that I'll be particularly looking for are around sort of maths or engineering maths of some form, some evidence that you've got circuit analysis or kind of introductory power systems. So highlighting that and showing it, giving a full transcript of what you've done and highlighting the particular things that you did in industry, particularly if there's sort of analysis or the use of sort of technical software, would be really useful in kind of assessing that application.
Absolutely. The more information we can look through, the quicker we should be able to come back to students as well with information. And as well, just to point out that when we do ask to see copies of your degree certificates and transcripts, I know some of our students may have been out of education for a number of years. They might be struggling to find this information, and you will need that as well once you do go through to submit a formal application. So even though we're asking for it now, it is beneficial if you are wanting to study the programme with us. You will, as this information will also be required further down the line. So when we do ask for it now, there is a reason for that. But I think, yeah, we've had a fantastic webinar today, and again, I'd just especially like to thank David for taking time out to join us and sort of go through his story.
Oh, you're more than welcome. It was my pleasure. Thanks, Lisa.
And of course to James as well for going through all the information with regards to the course. As I said, we are now accepting applications for February 2022 and also September 2022. So if you are considering studying with us, dare I say it's the 1st of December today, we'll be into the new year in no time at all. Please don't wait with your application if you are considering to study with us, but you have any questions, just contact me and we can book in a consultation to go through that. But thank you for joining us. And as I said, especially thank you very much to David for joining us today.